Hi, my name is William Garman, and today I'd like to show you my dissertation project for my Computer Science BSc. It's based on a personal project I developed. I'll add a link to the video on that in the description. That project was essentially a turn-based strategy game where the map is a Rubik's Cube that you can turn segments of. This project started with the goal of building an AI that would work within that game and be able to make decisions on how to turn the cube. However, over time it turned more into an investigation of the uses of fuzzy logic and fuzzy inferencing systems in game AI. As you can see in front of you, the game map isn't actually a Rubik's Cube. This is because the feature of allowing the AI to make decisions about how to turn the cube was dropped because I had to focus more on developing the fuzzy inferencing system. I won't go into too much detail about the fuzzy inferencing system here, because it's a very complex topic. However, I will add a link to my portfolio where I'll describe it a bit more. The one thing I will say is that whenever I talk about applying a value to a task, or applying a value to a unit performing a task, I use a Takagi, Sugeno fuzzy inferencing system to calculate that value, and it uses common sense rules and fuzzy sets to do that. But again, I'm not going to talk about that here, I'll talk about that in my portfolio. What I want to talk about, however, is the start to finish process of how my AI makes decisions. Every turn the AI completely restarts its decision making process, so even if it was halfway through a task, instead of seeing if it would be worth reassessing that task and possibly changing to a different one, it wipes it clean and sets it up as a new task. So to begin with, the AI wants to calculate its overall goals for that turn. These are categorized into aggression, which is how much it wants to destroy enemy units, expansion, which is how much it wants to capture new bases, and protection, which is how much it wants to hold on to its own bases. These values are based on things like, does the AI have more or less units and bases than its enemy? Are there lots of unclaimed bases? Or even how full is the map of enemy units? Once the overall goals are calculated, they're then used to calculate the value of performing individual tasks. A task could be to destroy an enemy unit, or capture an enemy base or an unclaimed base, or protect your own base. The value of a task will be based on at least part of the overall goals, and also individual aspects of the base or unit the task is referring to. For example, the task of capturing an enemy base is based on the expansion overall goal, as well as how close that base is to the fighting. Because if that base is closer to the action, that means it's probably reinforcing the enemy troops. Next, the AI finds which of its units can do which tasks, and how valuable it would be to assign those units to those tasks. This is done in 3 stages, each based on the value produced by the previous stages. The first stage is calculating basically how long it would take the unit to perform the task. So for destroying a unit, how long would it take to get in range, and then how long would it take to actually deal enough damage to destroy it? So for example, if it takes 2 turns to get within range of the enemy unit, and then on average 2 turns to destroy it, the value of assigning that unit to that task is the value of the task divided by 4. Next, that value is changed according to how close it would get the unit to performing other tasks. For example, you've got one base that's close to a unit, or in the other direction there's a group of 3 bases that are a bit further away. It's better to go for the group of 3 first, because you can do them in a quick succession. Finally, the collaborative value is calculated. This is based on how well suited the unit is to the task compared to other units that can do the task, and how well suited it is compared to the other tasks it can do. The basic idea is trying to make sure that units are doing the task that they are in the best position to do, while trying to make sure that they're not doing tasks another unit is far more suited to doing than them. After that, the AI simply goes through each of its units and randomly assigns them a task, with the likelihood of each task being assigned based on the collaborative value just calculated. In the video you're watching, the AI is playing off against another AI based on the same system, but instead of using fuzzy logic, it's using crisp logic. Again, if you want to learn about the differences between the fuzzy and the crisp logic AIs, then head over to my portfolio. Apart from that, I hope you enjoyed watching this, and I hope you'll check out some of my other work.